All right. We're now moving on to final chapter for our calculus class. Not the final chapter of the book, of course, but the last chapter that we'll be covering in Calculus 1. This is the chapter where we start to talk about integrals. So if you have gone this far in the previous class, or just from hearing stuff from other people, it's a big world, and I'm sure that you've had exposure to lots of ideas by now. You might have heard that there's such a thing as differential calculus, and there is such a thing as integral calculus. And we're going to be exploring that other bit of calculus in the next couple weeks. Now, this is one of the great successes of calculus. This is one of the things that really put this mathematical technique on the map and got lots of people interested in performing this kind of work, or at least using it to better understand the work that they were already doing. So classically, if you go back to pre-calculus times, people were very interested in geometry, and they still are today. You can even take some pretty cool geometry classes at this university. And what is the thing that we care about most in geometry? Well, lots of different things, but area comes to mind. So these days, it's not difficult to work with a circle to find its area. I know that I'll have some radius, call that r, and by now, we'd hope that people are familiar with the area formula. The area of this circle is pi times the radius squared. But what good is that if I don't actually know what the number pi is? I've heard that pi is 3.14, but I've also heard that it's irrational. Where does it come from? The decimal expansion for pi isn't written in the stars. It's not something that grows on trees. How did we get it? What kind of work does that take? And even once I know where pi comes from, if I'm the kind of person who cares about that, more broadly, how can I find areas of other things, other shapes? So what we are going to start off with is area, or the area problem. So given a curve, how much area is enclosed by the curve? It's a pretty straightforward question to ask, but there's lots of different curves, right? Here's one. What's the formula for it? I don't know. I just sketched it by hand. Maybe we could find some kind of formula for this, but we'll want to stick to problems that are a little bit easier just for getting started off the bat. So if I graph a curve, the fact that I was able to tell a computer what to do kind of says that I have an equation or something governing what that graph should look like. So can I find the area enclosed by this graph? Well, it's not really a graph in the way that we've been talking about graphs, right? This thing fails vertical line test. Let's look at something easier than whatever this is. Okay, well, here's a familiar shape. Has some amount of area inside of it. Can I find what's inside? Can I find the amount of area enclosed here? Well, this picture is built up from, looks like 7 different pieces. So that's still a bit more complicated than I want to start out with. Maybe we can find the area given by this figure later on. Again, let's start out simple. Okay, oh, no, let's not do this one either. How about, oh, a nice sine function. Okay, this is the graph of a function. It's nice and simple, but where's the area?